Lesson 4-3 is entitled the ASA and the SAS Congruence. And so hopefully by the end of this you can say I know the ASA and the SAS postulates, and I can recognize ASA and SAS relationships between two triangles. Now, that seems probably like a whole bunch of code that I was talking about. Let me break down. ASA stands for angle, side, angle. And as you probably can guess, then SAS stands for side, angle, side. So we are going to be dealing with the angle, side, angle congruence and side, angle, side congruence. Before we deal with talking about the angle, side, angle, and the side, angle, side, let's talk about congruence. Again, this symbol here means congruent. It's a equal sign with a little tilde kind of over the top of it. And so if you are going to state that two shapes are going to be congruent, you would say one shape on the other side is congruent using this symbol here to the other shapes on the other side. This can become really important when we deal with proficiencies again. This would be a new proficiency that we're going to be dealing with, where I want you to be able to you're going to be using these congruences to create proofs, but then you're also going to have to name them correctly. And again, this was kind of the downfall of people last year, is that the proficiencies are structured in a way that it might not be straightforward. If you're going to name these two shapes and you're going to say that they are congruent to each other, you would say that if I use the order A, B, C, I would have to use the same order on the other side, which is X, Y, Z. Notice how I'm starting with the A, which is the angle with the one line, and so I'm starting with X, which is the angle of the other line. So make sure that if you are starting with one of the angles, you are then starting with the corresponding angle or point that is the vertice on the other shape, and following the same exact order around. So I'm going from the 1 to the 3, from the 1 to the 2 to the C doesn't have anything. So I'm going from the 1 on X to the 2 on Y to the nothing on Z. If I'm going to say that A, B, C is congruent, using that little equal sign tilde, to X, Y, and Z. A couple words that you need to know. Included. Please write this down in your notes. Included basically means when a part of the triangle is in between two other parts. And so just a note to use that they have to be right next to each other. So again, I would say, based on these two pictures here, I could say that AB, the actual side itself, the distance of AB, is included by angle A and angle B, basically meaning the side is in between the two angles here, and they have to be right next to each other. I couldn't say angle A and side AB and then angle C. It'd say they have to be in order, so it goes angle, side, angle, side, angle, side, alternating. So that would be included. Opposite, when the part of the triangle is on the opposite side of the triangle. For example, angle C is opposite the side AB. Angle C here is opposite, right, AB. It's on the opposite side of it. And so on one side you have the side, and on the other side you have the angle. If I was going to say the opposite the opposite of angle B would then be the side AC, or the opposite of angle X would be YZ, or the opposite of XY would be Z there. And now the ASA postulate. Please write this down. Now if you actually quote this in an actual theorem itself, you can state the ASA postulate. You don't have to write this entire thing, but just for right now, so you have it in your notes, and make sure you get this on your cheat sheet, that if two angles and the included side of one of the triangles are equal to two angles and the included side of the other triangle, the triangles are congruent. And so if I take a look at what does that mean, that means that if I have two angles here, so I have angle B and angle C, and the included side, basically meaning the side that's in between these two angles, has to be the side in between. Please note that. and the included side, and the two angles and the included side of another triangle are equal. So as you can see, B is congruent to E because we have the line there. EF is congruent to BC because I have my sides are equal to each other, and angle C is equal to angle F. And so the two angles and the included side of another triangle, then I'm able to conclude that the two triangles are congruent. If you need to see kind of a description of this or as why this is true, you can take a look at page 147, 147 in your book, and kind of read over that extra piece there. The last piece, I told you this. Well, I hopefully told you that this was going to be shorter. SAS postulate. So the side angle side postulate means that if two sides in the included angle of one triangle are equal to two sides in the included angle of another triangle, then the triangles are congruent. So kind of looking at the same exact thing, if I have two sides, meaning AB is congruent to DE and EF is congruent to BC, and the included angle of B and the included angle of E are congruent to each other, then I may conclude that these two triangles are congruent, meaning they are exactly the same triangle, or at least they have the same measurements. They are the exact same shape and size of each other. Please make sure you have these written down. We're going to go through some proofs in class, and then be able to hopefully get some more of the homework done. So again, have these notes for next class period, and I will see you then. So, see you later.